Hello everyone, this is Richard Eaton, your CTEC 134 instructor for database administration. This is a continuation of the video series that we started dealing with a concept called functional dependence and normalization. In the part one video, we dealt exclusively with functional dependence. And then in the part two video, we managed to complete our discussion of first normal form, which deals with repeating groups. And we got partially through the second normal form rule that deals with partial dependencies or columns that don't depend on the entire primary key. And I wasn't able to finish that in a timely manner, so I'm picking up this part three video, which will be last of the series on these two subjects. So back to the PowerPoint presentation. The part two presentation, we looked at issues with redundancy and anomalies like update, inconsistency, additions, and deletions. And then we looked at a sample table and we looked at the definition of second normal form. And to repeat, a second normal form violation is a table that is in third normal form, but no non-key attribute is dependent on only a portion of the primary key. Another way of saying it is a non-key column must depend on the whole key, not just part of it. And then we did say that you can't have a second normal form violation if you don't have a compound primary key. In other words, if your table has a single column primary key, you don't have to even worry about second normal form violation because that can't happen. This is actually the solution to a second normal form violation, but let's go back to the table, this table here, and examine it a bit. In this case, what is our primary key? A primary key in this table cannot be the order number because we see here that 51610 is repeated, 51610. The reason why it's repeated is that there were two items on that particular order. Down here, there are three items on 51623. So we have 1, 2, 3 rows with duplicated numbers here. So the order number itself cannot be a primary key. But if we combine the order number and the item number, and we think of them as being just one single value, like 51608 CD33, or 51610 KL78, 51610 TR40. If we think of that, then the combination of these two columns are unique, the order number and the item number, and so therefore they can be the primary key. So let's say that is our primary key, the combination of order number and item number. Given that, we could say that the order date is a non-key field, the description is a non-key field, the number ordered is a non-key field, and the quoted price is a non-key field. But look at this situation. The order date. Do we need to know the item number to know what the order date is? No, we don't. We really only need to know the order number. So we could say that the order date is dependent only on the order number. And so that is actually a second normal form violation where we have a non-key field dependent on only a portion of the primary key. Look at the description column. The same is true here. Is the description column dependent on the entire primary key? Do I need to know both the order number and the item number to determine the description? Well, no, we don't. The description is determined by the item number and only by the item number. So we could then say that this is a second normal form violation. The description depends on only a portion of the primary key, the item number, and not the entire primary key. But these last two columns, the number ordered and quoted price, those two columns are fully dependent on the entire primary key. I would have to know both the order number and the item number to determine the number ordered and the quoted price. And so these last two columns are not a problem. This is a problem here, the description, and the order date is a problem. And the solution is really to put these two columns in different tables. And so here's what that would look like. Here's our original table. Well, maybe I'll make it. Here's our original table here. And here is our solution. We take the order from here and the order date from the original table and put them into a table by themselves. Okay? And we would make the order number the primary key, and the order date is a non-key field fully dependent on the order number. We would do the same with the item number and the description. We would create a new table with an item number and a description, and we would make the primary key the item number here in this item table. So we have an item number that determines the description. The description is fully dependent on the item number, which is the primary key. So what we've actually done is we've created a new table. We've duplicated the order number here. The order number is still, order number has moved to the orders table, and the order date is moved to the orders table. And then we have a new table called item. So we have an item number, primary key, and a description. We would also have in our final solution maybe a quoted price or number on hand, things like that. We'd have some additional fields in here. But here's the table that brings these two tables together. It's a third table that takes elements of these two and puts them together. It's actually a many-to-many relationship. So you see in this order line table, we've taken the order number from here and put it in the order line table. And we've taken the item number on that particular order and included that in our second column of the order line table. And then we made the order number and item number the primary key, because collectively these two things are unique. And then we took the values from the order number column and the quoted column, and we included those in this new order line table. So what we have then is, and it is three tables that are in second normal form. Okay, we have no non-key attributes dependent on only a portion of the primary key. And this particular concept is a little bit hard for beginners to grasp, but once you look at a few of these examples, they become second nature, and you'll end up, when you're building databases, after you have a little bit of experience, you'll just do it right from the get-go. Third normal form. In third normal form, update anomalies can still exist. And that's when we have the situation when an attribute or field or a column functionally determines another attribute in that column. Or a better way to say it is if we have a non-key field or a non-key column that functionally determines another non-key column. Here's an example. In the customer table, customer number is a primary key, and this is the rest of these columns are non-key columns. Okay. Customer number functionally determines the name, the balance, the credit limit, and the rep num. But look at these last two here. The last name field here is not functionally dependent on the customer number. It's functionally dependent on the rep num. Same with the first name field. It's functionally dependent on the rep num. So what we have here is a non-key field that's dependent on another non-key field. Over here, the first name is a non-key field that's dependent on another non-key field. And the solution to that is to create yet another table with these three columns and put them in a table by themselves. And we would leave, in particular customer table, we would leave the rep num column here by itself. And these last two would be removed from the customer table because these three columns are now into a table by themselves. And let me make this a little bit bigger so we can see it. So the solution here was to take these three columns and put them into a table down here. Make the primary key the rep num field, and this is a non-key and a non-key. And we took these two columns here, the first and last name, out of this table. And so now the customer table has a primary key and four non-key fields that are fully dependent on the primary key. And that's third normal form. And I hope this was useful. You might need to look at it and study it a bit more in order to get really familiar with it. And in Canvas, I'm including some other videos or Google links that will further explain normalization issues. But that's it for now. Thank you.